Hello and good afternoon, everyone. I welcome you all to India's largest e-learning platform, Unacademy, and I welcome you all to our channel, Gate Conqueror. And this is a new series, Antennas CTQ series, Concepts Through Question series, and we are into part 11. This is an important series because parallelly you have a scope to learn both concepts and questions. So this kind of series will help you out in revising or building up your concepts to the core. So ask all of your friends also to join dear. This is going to be a very important session. Ask all of your friends to join. These kind of sessions will be very much useful for you people. Before we start the session, let me introduce myself. I am G C Reddy. And 15 plus years of experience in teaching, guiding and mentoring GATE and ESE aspirants. I work as motivational speaker pan-India from the past 12 years. Expert in field theory and communications. This is the official link where you can join us on Telegram. The advantage of joining us on Telegram is that you get a personal level access with all our faculties of the Gate Conqueror team. Recently, the good news for Gate Conqueror followers is recently 4 new educators added to our channel, 4 experienced people, 4 knowledgeable people, 4 excellent talented people joined us. Now we are a team of 8 people. We have an English speaking channel where we will complete the syllabi for GATE 2023. We are determined to complete the syllabus for GATE 2023 and ESE 2023 comprehensively. If you want the comprehensive coverage of GATE 2023 and ESE 2023 syllabus completely in English, then as far as I know, there is no other channel which is purely dedicated or they teach classes in English. So ours is a purely an English channel where the educators will be communicating with you only in English. So this is a wonderful platform dear, and we are geared up to finish off the syllabus of GATE and ESE 2023 comprehensively and see to it that you get very good ranks. And my responsibility in this channel is to finish off EMFT, electromagnetic field theory, for ECE. For ECE people, to cover both GATE and ESE. EMFT subject for both GATE and ESE. A subpart of it, EMF for triple E for both GATE and ESE. My responsibility is to complete communications for ECE, for GATE and ESE, and communications for electrical for ESE. And to communicate and to complete advanced communications for ECE for ESE exam. So these are my responsibilities, dear. And for this we have created a playlist with 40 videos and 50 hours of content titled Elements of EMF Theory. We had completed both GATE and ESE India. Some practice questions are left out. Other than that, we had completed this particular target. So if you are from electrical, you can prepare right away for your EMF for both GATE and ESE. The maximum content that you can find for elements of EMF theory is around 8 to 10 hours. Against that, we got 50 hours of content already uploaded and are ready to solve a minimum of 200 more practice questions to this particular playlist. Already it is like 5-fold to 6-fold greater than what other YouTube channels offer. So I can say the GATE Conqueror channel is a one-stop solution for all those who want to learn the concept in English and all those who want to learn elaborately and comprehensively. Just not a 1-fold or 2-fold here. It's like 5 to 6-fold more content we have delivered. Please go through this playlist. Electrical people can straight away start their preparation for EMF. Whereas for EC, you have EMFT, which will have 5 modules, and this is one module of it, module 1. How far we had completed these EMFT, I'll try to explain. Once we start the class, I'll explain what we had completed in EMFT. This is only for your knowledge, that what all content that you have on our channel. I told you, Bhaskar, yes, we'll start here. From Monday, I am starting transmission lines. It is already scheduled. From Monday, we'll start transmission lines, dear. Is that clear? So don't worry, Bhaskar. We will start transmission lines from Monday. And today, and Bhaskar, today we'll finish off module 2 also. EM wave propagation we are going to finish today. Okay? Stay tuned. In the evening I'll take a session. We'll finish EM wave propagation. Unacademy offers 2 paid platforms. One is Plus subscription. There is Iconic subscription. In Plus subscription, you got to have the first time of legendary faculties in the form of live classes, weekly test, structured courses, unlimited access, rank improvement batches, and crash courses. Generally, on other online platforms, dear, rank improvement batches will be separate, crash courses will be separate. That means other than the regular GATE and ESE course that you take, you need to purchase separately for rank improvement batches and separately for crash courses. You need to pay them separately, which is not the case here at Unacademy. Within the Plus subscription itself, you will have all your weekly test structured courses, rank improvement batches and crash courses also. Try to understand the difference that we bring to the quality of education. Iconic subscription includes all the features of Plus subscription. Along with that, we'll have a personal coach for one-on-one guidance. Having a personal coach is really important if you want to save your time and energy and always want to move in the right path. All that experience of the coach will be useful for you. Dedicated doubt clearing educators. Clearing doubt and clearing it on time is very, very important to keep the motivation levels of the students. Keeping that into mind, we are determined to clear the doubts within 24 hours. So that's a promise, dear. We clear your doubt within 24 hours. And also we'll come up with a video solution. You need to understand that. Preparatory study material like practice sets, specialized notes, all these are very, very important here, which will give you an edge to succeed over others. Personalized test analysis. See, writing test is a very important thing. I never say that it is not important. Writing test is a very important thing. You should never face the final exam directly. You should understand how that final exam feels like. You must be ready for that particular exam mentally and physically. To do that, you need to understand what it contains, how many questions they will ask, how to manage the time, how many questions you need to attempt, what is the computation for this exam, how are the computators. You need to do a lot of analysis. You need to understand what are your strong subjects, what are your weak subjects, and how to overcome these weak subjects and up to what percentage at least we must achieve in weak subjects. How many subjects you can leave it completely, or is it possible to leave it or not? So all these combinations and permutations we need to do to understand or to do better in exam. So this personalized test analysis is also very important, because writing the test is not everything. After writing the test, you must identify your strength, weakness, opportunity and threat. That analysis you must do, and your personal coach will always help you out in this analysis, which is a very important part of your preparation. Preparing is important, but preparing in a correct direction is also very, very important. Study booster sessions. We'll have regular workshops, essential guidelines and all will be given in the study booster sessions, and a customized study planner which will be tracked by your personal coach. We strongly believe that a planner designed for a student may not work for another student, because no two students are same. That thing may not work in that way. That's why it's very, very important here. It's very, very important to have a customized study planner. Having a customized study planner is very important. And if your personal coach will help you out in designing this customized study planner. I'm thinking like Bhaskar, time won't be enough, because we are dealing with concept through question series also. So what we'll do is, we will start transmission lines, then we'll start waveguides, then optical fiber communication. Anyways, nothing to worry, Bhaskar. It's only April now, so at least by mid of May we'll complete EMFT. Still, you have lot of time, at least 6 months of time you have for preparation. So I think that must be enough. Is it not, Bhaskar? That must be enough, am I right? Unacademy offers 2 paid platforms. One is Plus subscription, other is Iconic subscription. Whether you go for Plus subscription or Iconic subscription, you go for no cost EMI. What is no cost EMI is total cost will be divided by number of months without any extra cost, and this no cost EMI is available on 6 months and above subscription. Moreover, you can use our team code KNR10 to avail extra 10% off. Iconic subscription, 1:1 live mentoring, increasing your chance of getting a top rank. This is GATE and ESE Iconic subscription. You get benefits like you have a personal coach, one-on-one live mentoring or 1:1 live mentoring, online study material, you'll have priority in Ask a Doubt, you have live doubt solving sessions for every 3 classes. There will be 1 doubt solving session. That is how it works, dear. You'll have live doubt solving sessions. See, live doubt solving sessions are very important actually, because at times what happens is we people will stuck at a given doubt and we can never move forward from that particular doubt, because back of our mind we always think about that doubt. This will hamper our preparation seriously. To overcome this, dear, keeping this into context, for every 3 hours we have a doubt solving sessions, that you are live doubt solving sessions, so that you can clear your doubts and move forward in your preparation. You will be given priority in live classes using raise hand option. You will have open house with educators to have a personal level interaction. Also encourage community learning. Along with that, you'll have all the extra benefits of the Plus subscription. Especially you have the rank improvement batches, which are the main benefit of Plus subscription, will also be included here. Generally, as I told you, rank improvement batches and short courses, like you have rapid courses, they are generally charged separately. We include it within the Plus subscription, and of course Plus is again included in Iconic. So with Iconic subscription, you'll take your preparation to the next level. I sincerely request you to consider for an Iconic subscription for GATE and ESE preparation. And we also give you a free physical notes for GATE Iconic 1 year and above subscribers. We are ready to give free physical notes for GATE Iconic 1 year and above subscribers. All those students who subscribe with 1 year or more subscription for GATE Iconic, you will be having the free physical notes which are curated under India's topmost educators, which has comprehensive syllabus coverage, solved examples to build problem solving skills, available for electrical, EC, mechanical, civil and computer science. And the notes will be dispatched to you starting from last week of May. And if you are having these physical notes designed by the India's topmost educators, then definitely you will have the edge over others. This is Unacademy Lite subscription, which includes mix of topic and subject wise mock test. Mock tests itself are very important here. And instead of a complete subject or multi-subject, simple subject-wise or topic-wise mock tests are very, very important, which will build up your expertise. The smaller the topic it is there in the mock test, the more expertise you get in that particular topic. I really love for topic-wise mock test because it gives me expertise in that particular topic. Later on, once you start doing topic-wise mock test, later on you can do subject-wise mock test, then you can do similar subjects group mock test, then you can do two different subject mock tests, one from field theory, other from circuit theory, one for communication, one from circuit, in that way, so that your brain will be trained up to deal multiple kind of questions at a given frame of time. Then you will have some interlinked subject mock test. All the three subjects which are interlinked, you will have a mock test on that. Multidisciplinary subject mock test. One from EC, the other from like computers where you have CO and all. The basic core is from other branch. Such kind of mock test. Structured test series where we in hand tell you the number of tests that you are going to write and whether they are full length, topic wise, subject wise, multi subject, cross subject and all. And also after every mock test, detailed solutions and performance analysis will be done through this Lite subscription. Because of having all these features, I say this Unacademy Lite subscription is a very important feature, a very important part of your preparation. You can subscribe now for the Lite subscription using our team code KNR10. This is Unacademy Ultra Combat, the new one for GATE and ESE aspirants. You have so many exciting things to understand here. First and foremost thing is, questions are curated by top educators. If you are writing a combat here, I recommend you just one thing. If you are writing a combat, I just recommend you one thing. Please make sure that combat is curated by top educators. Writing a combat which is below a given level will actually hamper your knowledge. So you must be very choosy while you select your combat. As you know, at Unacademy, combat is not designed. Any Unacademy combat is not designed by the back-end team, but the educators themselves design the combat. India's topmost educators will design this combat here. Therefore, you can expect some excellent questions in this combat, which will always improve your knowledge. Top rankers to win 100% scholarship, that is free subscription and exciting gadgets. You can see all the gadgets here, along with some gift cards or gift vouchers. You stand a chance to win all of this. This Unacademy Ultra Combat is on April 24, 11 a.m. Any speciality of this April 24? Anyone? Any speciality of this April 24? One, it is a Sunday. Two, it also marks the birthday of Sachin Ramesh Tendulkar, a brand ambassador of our Unacademy. So let us all get up to the special day, and I hope you people also, by writing Ultra Combat, will make this day more special for you people. And lucky participants are also to win Amazon gift voucher worth rupees 5,000. And by writing every Sunday, if you write a combat here, and this combat contains live quiz questions designed by India's top-notch faculties, top-notch educators, then I think definitely you will have the chance or edge to crack this exam comfortably. Not just crack here, but also to top the exam. And the good thing is, there is no enrollment fees to write this combat. It is completely free. You can enroll using the team code KNR10. Enrollment is free here, so let us all get up to showcase our talent and come up with flying colors, win all these gadgets, special event, free subscriptions, and start preparation with India's topmost faculties. For all talented students, this is the best platform to showcase your talent, my dear friends. This is what I was talking about, the Unacademy Ultra Combat. Your action plan to crack GATE and ESE exam. It contains 30 questions and 60 minutes. Will be conducted on April 24, Sunday, 11 a.m. These people must draw some inspiration in you, because these are our students who had top these exams comfortably. This is Unacademy Ask a Doubt feature, where you can ask unlimited number of doubts at a go. Available both on app and website. You can ask 3 doubts at a time. Just a second here. And also get the solution in your preferred language. It's also very easy to ask your doubt. Just click, crop and submit. Yes, Karna. Good afternoon. Sure. Thank you. Srikanth, good afternoon. Anil, good afternoon. Which subject they will include in this? Your basic subjects, the basic subjects that will be asked for GATE the same subjects will be replicated here for this combat. Just any more doubts? Good afternoon, Surendra. Yes, you can ask your doubts here. Anyone, any doubt, you are welcome. Get in touch with counselor. That is what I was telling you. Get in touch with counselor. If you are confused about your preparation journey, if you are having queries about the subscription, or you want to know about the latest offers, just call our counselor. They will definitely help you out in your preparation journey. These are special class features which includes interactive live classes for the learners, polls for the learners. Polls are really proved to be a very important model of learning, very effective model of learning. Raise the hand option which gives you interaction or the field that is required for any offline class. That offline class field that you get by using this raise the hand option. And you never miss a class when the notification is on. Just follow my profile and you'll get all the notifications when I'm going live. The notification will be given at least 10 minutes before for you. And you can download the lecture notes once the class is done. And of course you can access anytime and anywhere. These are the new batches dear. Every week around 7 to 8 new batches we start. These are the new batches for GATE 2024. For electrical explained in English started on April 13. You can use our code KNR10 which is our team code which gives you extra 10% off and complete team support. This is PAR GATE 2023 for electrical explained in English started on April 13. Here also you can use our code KNR10 to avail extra 10% off. This is where GATE 2024 for ECE explained in English start again on April 13. This is one more batch. Here also you can use our code KNR10 to avail extra 10% off dear. This is PAR GATE 2023 for ECE explained in English start on April 13. Here also you can use our code KNR10 to avail extra 10% off. So kickstart your preparation for 2023 and 2024 dear. Using our new batches you can join. Remember my word, you can join any number of courses within that particular time period of subscription which is not available in other platforms where you must restrict yourself to any one batch. We are into the antenna CTQ series. We are into antenna CTQ series dear, which is part of our EMFT. Which is also part of our EMFT. This EMFT contains 5 modules. And these 5 modules are, we'll discuss one by one about these modules and the playlist that we have created and how the GATE Conqueror channel will help you out in this preparation. We'll deal it one by one. Then also we'll do some wonderful questions on antenna arrays today. Today's topic focus on antenna array concept 3 question series, where we discuss about the questions related to antenna arrays and also elaborately we'll discuss about the concepts related to antenna arrays. So antennas being a part of EMFT syllabi. This EMFT syllabus contains 5 modules. Of this 5 modules, module 1. What is module 1 dear? Module 1. Elements of EMF theory. Of this 5 modules, Module 1 is elements of EMF theory. This is for both ECE and electrical, on which we had created a playlist already with 40 videos and 50 hours of content, completing the syllabus for both GATE and ESE. For electrical people, this is a complete syllabus of EMF, and for ECEs, it is one of the module. Out of 5, it is one of the module for ECE. So this is also a very special playlist here. Generally, for elements of EMF theory, the maximum content that we find on any YouTube channel will be around 8 to 10 hours. Well, we got 50 hours of content here. That's the specialty of this. And you got module 2. Is EM wave propagation. Module 2 is EM wave propagation. This for EC, and a playlist on this is also created. Today we will finish this module here. Already a playlist is created with 15 videos and 30 hours of content. This playlist is already available, where we finished 90% of the syllabus for both GATE and ESE. Some wonderful derivations, concepts will be explained. That will be useful for ESE as well as for GATE. Yes, Deva Tirthagiri. Tell me, dear. Any doubt? Any doubt? Please let me know. That's module 2, and module 3. What is module 3, dear? Module 3 is transmission lines. Module 3 is transmission lines. This we are starting next Monday. The next Monday, coming Monday, we'll start this. Module 4 is waveguides, which includes both rectangular and circular waveguides. Module 5, optical fiber communication, which will be started very soon, and antennas. And for antennas, we had already created a playlist with 18 videos and 38 hours of content. So overall, for module 1, we created 50, we have 50 hours of content. Module 2, 90% completed already, and it has 30 hours of content here. Module 5, a part of it, which is antennas. Exclusively, we had covered all the antennas here, including the 7 sisters. No, I can tell one thing here, no other online platform will explain you 7 sisters. Such very important 7 sisters were discussed. Already 118 hours of content is ready on our channel, and I am ready to take 1 or 2 hours more and make this EMFT a 220 hours of content like never before. 220 hours is ultimate. You can never think beyond this. Generally 30 to 35 hours of content is what available for EMFT subject on any YouTube channel. Now you just imagine how many more folds we had completed here. Once I finish this 220 hours of EMFT, and once this is done, we'll start communications, and which is a 300-hour course. 300 hours only communications. Just be ready for that. Clear, dear? So what we are seeing under module 1, we'll see. Module 1 is elements of EMF theory. As I told, it is common for EC and electrical. Here we have created a playlist with 40 videos and 50 hours of content. In this module 1, elements of EMF theory, we segregated into 3 parts: basics, static field theory, and time varying field theory. Time varying field theory. Under basics, divided this basics into 2 parts: elements of vector calculus and coordinate system. Elements of vector calculus and coordinate system. Okay. One second here. Just give me 1 second. One second, one moment. Fine. Under elements of vector calculus, let us see what we are seeing under Elements of vector calculus. Under elements of vector calculus, started our discussion with scalar. What is scalar, dear? What is a scalar, dear? Scalar, anyone? What is a scalar? Scalar. A scalar is one which has only magnitude, no direction. Examples of scalars: distance, time, speed, mass, density, these are general examples, general physical examples. Technically, electrical quantities, voltage, current, power, all these scalar quantities, work done, all these are scalar quantities. And the scalar is represented by a simple ABC. Next, vector. A vector is one which has both magnitude and direction. Examples: velocity, displacement, acceleration, power density, current density, force, torque, and many more. And here also, dear, so many people will think that current is not a scalar. They think that current is a vector, but the fact is current is scalar. Please go through my previous videos, dear, where I done a video on why current is scalar. I done a video on why current is scalar. Please go through it, dear. There's a wonderful video on that. Just go through that particular concept, why current is scalar. Third one is unit vector. These vectors are given by arrow on it. Unit vector, which gives you the direction of the vector. If you take Cartesian coordinate system, unit vectors are ax, ay, and AZ, where AX, AY, AZ are unit vectors along X, Y, Z. It gives you the direction along X-axis, Y-axis and Z-axis. This is Cartesian coordinate system. This is X-axis, this is Y-axis, and this is towards me, Z-axis. The unit vector along X-axis is given by AX. Unit vector along Y-axis is given by AY. Unit vector along Z-axis is given by AZ. So these are unit vectors. And you know, vector is given by the magnitude of the vector into direction. But the direction of the vector gives you unit vector is given by unit vector. Therefore, direction of the vector is vector by its magnitude. Therefore, unit vector is defined as any vector to its magnitude. Any vector to its magnitude is defined as unit vector. Clear? Clear? Next. Addition of vectors. Addition of vectors can be done by parallelogram law rule or parallelogram rule. And head to tail rule. Head to tail rule is also called as triangular rule. Again, I just don't want to go into the details of this parallelogram law rule and head to tail rule. Please go through the playlist for in detailed analysis of parallelogram law rule and head to tail rule, especially triangular law or head to tail rule. Very interesting concept we have discussed there. Please go through it. Then we had seen the basic laws of vectors, basic laws of vectors. And the basic laws of vectors we have seen commutative law, associative law and distributive law. So anyone? What is commutative law of addition? Anyone? What is commutative law of addition? What is commutative law of addition? Anyone, dear? Commutative law of addition. One second. Commutative law of addition. If A and B are two vectors, commutative law of addition A plus B is equal to B plus A. Multiplication. If K is a scalar and A is a vector, K into A is equal to A into K. The first one is commutative law of addition. The second one is commutative law of multiplication. Next is associative law. If A, B, C are three vectors, A plus of B plus C is equal to A plus B plus C. Associative law. Multiplication. K into LA is equal to K into L into A, where K and L are two scalars. It's just distributive law. K is a scalar and A and B are two vectors. K into A plus B is equal to KA plus KB. This is distributive law of addition. Now please someone tell me. Distributive law of multiplication. Yes, dear, you can ask. What do you want to ask? You can ask, dear. What is distributive law of multiplication? Distributive law of multiplication. Anyone, please? Distributive law of multiplication. Anyone? Think and tell me what is distributive law of multiplication. Anyone? Distributive law of multiplication, anyone? Think and tell me a logical thing that is. What is distributive law of multiplication? No one? Easy, easy, easy. Come on. Distributive law of multiplication, anyone? There is nothing like distributive law of multiplication, remember. That's why you are not able to recall. Because distributive property is already used in addition itself. Got it? Sixth one. In simple words, I like to tell you why current is scalar also, because some people are asking me why current is scalar. I'll explain. See here, why current is scalar. Current is scalar despite having both magnitude and direction. It is not a vector, because vector is one which has both magnitude and direction, and which obeys vector addition. Vector is one which has both magnitude and direction, and it obeys vector addition. Now, why current is scalar, I'll tell you. If you take head to tail rule, according to head to tail rule, if you draw a vector here, you have two parts here, this and this. This is called the head of the vector. This is the tail of the vector. According to head to tail rule, if A and B are two vectors such that the head of A joins the tail of B, the resultant vector C is equal to A plus B. Starts at tail of A, ends at head of B. This is head to tail rule. Why current is scalar, I'll explain, and why it does not obey vector addition, I explain. If you consider now, this is IA, current flowing in this element is IA, and this is IB, and this is IC, which is IA plus IB. If you calculate the total amount of current at this point, it is IA plus IB. Now this is IA and this is IB. Total current is IA plus IB. If you take one more vector like this, which is minus IC. Minus IC is minus IA minus IB. And if you calculate the total current at this point, up to here it is IA. Up to this it is IA. Up to this it is IA plus IB. Now if I reverse it, this IC will become minus IC. So what is the total current here? Total current I is equal to 0. But my dear friends, is this an open circuit or short circuit? 1, 2, 3. What I am doing here? It is a short circuit. For short circuit, how much is current? 0 or maximum? It must be maximum. How much current you are getting here? According to vector addition, 0. That means what? Current does not obey vector addition. If it is obeying vector addition, the current for the short circuit must be 0. But we know that the current for the short circuit is not 0. So from this it is very clear that current does not obey vector addition. That's the reason why, despite having both magnitude and direction, current is not a vector quantity. It is a scalar quantity. Is that clear? Any doubts? Any doubts? So that's why current, despite having magnitude direction, it's a scalar quantity. It's a very important problem that I try to address. Then multiplication of vectors. Multiplication of vectors. One dot product. Also called as scalar product. To cross product. Also called as vector product. What is dot product there? Dot product is also called as scalar product because dot product results in a scalar quantity. Therefore, dot product is also called as scalar product. If A and B are two vectors, A dot B is mod A mod B cos of theta AB. This is when angle is given. A is a vector, B is a vector, theta AB is the small angle between A and B. This is a small angle and this is a larger angle. Larger angle means this one. This is a larger angle. Theta AB is the small angle between A and B. A dot B is given by mod A mod B cos theta AB. This is when angle is given. This is when angle is given. And when angle is not given, A is AX plus AY plus AZ. B is BXAX plus BYAY plus BZAZ. A dot B is AX BX plus AY BY plus AZ BZ. This is when angle is given, and this is when angle is not given. And also let us see dot product obeys which basic laws. Does it obey commutative here? Does it obey commutative? Dot product obeys commutative law. That means A dot B is equal to B dot A. Yes, it obeys commutative law. Associative. Does it obey associative law? Does it obey associative law? Associative law means A dot B dot C is equal to A dot B dot C. But is it possible to write it in this way? Anyone? Can we write A dot B dot C as A dot B dot C? Not possible. Not possible. Why? Because B is a vector, C is a vector. B dot C is dot product of two vectors. It's a scalar quantity. And once this is a scalar, you cannot multiply a scalar and a vector. Writing this itself is not possible. So, this law is not possible. Dot product does not obey associative law. What about distributive? A dot B plus C is A dot B plus A dot C. It is distributive. So, dot product is commutative and distributive. Got it? That's about dot product. That's about dot product. Next, cross product. If A and B are two vectors, A cross B is equal to mod A mod B sin theta AB into An. A is a vector, B is a vector, cross product of any two vectors is one more vector. Therefore, AB sin theta AB, this gives magnitude of the vector and this gives you direction. Again, like if A is a vector, B is a vector, theta AB is a small angle between A and B. This is small angle. This one is a larger angle. AB sin theta is to the magnitude of A cross B. AN gives you the direction. This is when angle is given. Angle is not given. A is given as AX plus AY plus AZ B is BX plus BY plus BZ A dot B is equal to AX BX plus AY BY plus AZ BZ. That is for dot product. Already we had seen. Now, if it is for cross product, dot product is element by element multiplication. We had seen. Cross product, A cross B is determinant of unit vector of both the vectors AX, AY, AZ, coefficients of first vector AX, AY, AZ, coefficients of second vector BX, BY, BZ. That's about the cross product. This is when angle is given. This is when angle is not given. Now let us see which laws this cross product will obey. Commutative law. Does it obey commutative law, dear? If cross product obeys commutative law, A cross B must be equal to B cross A. Are they equal? No. That means what? It is not commutative. A cross B is equal to minus B cross A. It is anti-commutative. But my dear friends, I have a small doubt here. Is minus B cross A is correct, or minus of B cross A? Of this both, we have these two things here. Minus B cross A or minus of B cross A. My doubt is which is correct. Minus B cross A is correct or minus of B cross A? B cross A is correct. That we need to decide. Is it minus B cross A or minus of B cross A? So which is correct here? Minus B cross A is correct or minus of B cross A? Krishna, new educators will start their classes from Monday. Is minus B cross A correct or minus of B cross A? This is called property of determinant. Property of determinant. From this property, both minus B cross A and minus of B cross A both are correct. How? For example, if you consider a vector A, which is 2ax plus 3ay, and B, which is 6ax plus 4ay, then A cross B is determinant 2, 3, 6, 4 AZ. 8 minus 18 minus 10 AZ. Now let us find B cross A. 6, 4, 2, 3 AZ. 10 AZ. Very clearly, A cross B is not equal to B cross A. If you take minus of B cross A, minus of B cross A is minus 10 AZ. That implies A cross B is equal to minus of B cross A. Now you tell me which is correct. Which is correct? Which statement is correct? Which statement is correct? A cross B is equal to minus B cross A or minus of B cross A, which is correct. From this, the second statement is correct. But let me once verify minus B cross A also. Minus B cross A is minus 6 minus 4, 2, 3 AZ. This minus 10 AZ. That means what? Minus of B cross A or minus B cross A, both are same. Both the statements are correct. This is called property of determinant. Property of determinant. What is property of determinant? If K is a scalar, K into A cross B, A and B are two vectors, will be K into A cross B. That means in a cross product, if a scalar quantity or a constant is multiplied to one of the element, it is enough, we can take it common. Similarly, A cross KB is also equal to K into A cross B. And if this element is multiplied to both, we take it common 2 times K squared times of A cross B. Property of determinant. That is what is used here. Here the constant or the scalar value is minus 1. Is it clear? Okay. So commutative law is not commutative, cross product is not commutative, it is anti-commutative. A cross B is not equal to B cross A. A cross B is minus B cross A or minus of B cross A. No. Is it associative? Is it associative? A cross of B cross C, whether it is equal to A cross B cross C or not. A cross of B cross C is not equal to A cross B cross C dear. It is not associative. It is not commutative. It is not associative. Distributive. How to understand distributive? A cross B plus C is equal to A cross B plus A cross C. It is distributive. That's about cross product here. Multiplication of vectors, dot product and cross product. Then we went for del operator and its properties. Del, reverse of delta, is given in Cartesian coordinate system is given as dou by dou x of ax plus dou by dou y of ay plus dou by dou z of az. Del is called as vector differential operator. Del is a vector differential operator or spatial derivative operator. Del is vector differential operator or spatial derivative operator. It is called as vector differential operator because it's a vector in itself. It is having unit vectors ax, ay, az, and what it does is differentiation. Therefore, it is called vector differential operator. It's called spatial derivative operator because it will do derivative with respect to space coordinates x, y, z. Therefore, it is also called spatial derivative operator. Properties of del. Properties of del. First one, when del is operated with in association with the dot product on a given vector, it is written as del dot A and is read as del dot is read as divergence of A. Del is a vector, A is a vector, dot product of two vectors is scalar. Therefore, divergence of any vector is always a scalar quantity. And if that divergence is 0, then what do you call it, dear? If the divergence is 0, what do we call it? If the divergence is 0, what do we call it, dear? If the divergence is 0, we call it as divergence-less vector. Or solenoidal vector. If the divergence is positive, you call it as source. If the divergence is negative, you call it as sink. That's the first property here. Second, when del is associated with respect to, or del is operated on a vector using a cross product between them, it is written as del cross A. Del cross A is read as curl of A. Del is a vector, A is a vector, cross product of two vectors is one more vector. Therefore, curl of A is always results a vector quantity. Curl of A will give you rotation of A. Curl of A will give you orientation of A. Curl of A will give you orientation of A or rotation of A. If that curl is 0, then the vector is said to be irrotational, which cannot be rotated. It is not equal to 0. It is a rotational vector. It's a rotational vector. That's called when del is directly operated on a scalar. It is read as gradient of scalar. Gradient of any scalar is always a vector quantity. Examples: del dot A is 0, divergence less vector. Example, del dot B is 0, B is divergence less vector. Source, del dot D is equal to rho V. When the charge is positive, D is source. Del dot D is minus rho V. When charge is negative, it acts as sink. Irrotational vector, del cross E is 0. Static electric field is irrotational. Rotational vector, static magnetic field is rotational vector. Del cross H is equal to J, Ampere's law. Gradient of any scalar is a vector quantity. E is equal to minus del V. Example. See dear how closely we are trying to relate our subject to these properties. That's why this del and its properties, very important concept here. Eighth one, is on vector identities. What are the vector identities you got here? What are the vector identities we got? Divergence of curl of any vector is 0. Curl of gradient of any scalar is 0. These are two main vector entities. Also we can write del dot AB is equal to A dot del V plus V into del dot A. This can be written as del V dot A plus V into del dot A. We can write this because A dot V is equal to B dot A. Del V is a gradient of scalar which is a vector quantity. A dot some vector. Let it be del V is B. A dot B is equal to B dot A. Commutative law. Dot product of is commutative law. So I can write this in this way. From this del cross AB is del V cross A plus V into del cross A. That's why writing it this in this format will make things easy for you. Writing it in this format will make things more easy for you. Next is A cross B cross C is equal to vector triple product. A cross B cross C is equal to B into A dot C minus C into A dot B. It's called back minus cab rule. And del dot A cross B is equal to B dot del cross A minus A dot del cross B. These are all the vector identities here. With this we'll close the first part of the basics, elements of vector calculus. Very important concepts. Under basics part 2, and for coordinate system. In coordinate system we have seen types of coordinate system. Under coordinate system we had seen Types of coordinate system. What are the types, dear? What are the types of coordinate system? Types of coordinate system. One. Cartesian coordinate system, also called as rectangular coordinate system. Second, cylindrical coordinate system. Also called as circular coordinate system. Third one, spherical coordinate system. In Cartesian coordinate system, coordinates are x, y, z. In cylindrical, rho, phi, z. In spherical, r, theta, phi. What are the range of these coordinates here? Take x, y or z. The range is from minus infinity to plus infinity. If you take rho, radius of the cylinder 0 to infinity, phi azimuthal angle 0 to 2 pi, z height of the cylinder minus infinity to plus infinity. Remember, when you move from one coordinate system to another coordinate system, only two coordinates will change. The third will remain same, and the range once defined will not change. Maybe the meaning of it will change, but not the range. What does it mean? Means in Cartesian coordinate system, what is z here? Z is nothing but the distance on the z axis, distance parallel to z axis, shortest distance from xy plane. The same z in cylindrical coordinate system is the height of the cylinder. The definition is different, but of course the range is same. Here also the range is minus infinity to plus infinity. And remember, unlike radius, height is a reference quantity. Therefore, it will run from minus infinity to plus infinity. Any doubts in this, you can ask dear. Any doubt, anyone, you can ask. Next, the spherical coordinate system, coordinate range. R is the radius of the sphere, 0 to infinity. Theta is the co-altitude angle, 0 to pi. Phi is the azimuthal angle, 0 to 2 pi. So these are different types of coordinate system, the coordinates and their range. Then we went for point transformation. Then we went for point transformation. How to convert a point from one coordinate system to another coordinate system. Point transformation. How to convert it? Point transformation. How to convert a point from one coordinate system to another coordinate system. This is z-axis, y-axis, this is x-axis. This is x, this is y, and this is z. Point transformation. How to convert a point from one coordinate system to another coordinate system. First, Cartesian to cylindrical. Cartesian means x, y, z to cylindrical, rho, phi, z. Let me consider a point in the xy plane. The distance from the origin to that point is called rho. Radius of the cylinder, which is given by rho. And if you draw the projection like this, if you drop a projection like this is the line parallel to y-axis y, line parallel to x-axis x. This is x and this is y, and angle made from x-axis to rho is phi. Point transformation, Cartesian to cylindrical, x, y, z are available. We need rho phi z. Rho phi z. Z is z, no change. I want rho. Now this is opposite side. But this fellow is falling on this point at 90 degrees. The one opposite to 90 is hypotenuse. Therefore, rho is hypotenuse. Rho is hypotenuse. It's falling on some point A, OA. This is rho, this is y, and OA is x. That's the adjacent one. Cos phi, adjacent by hypotenuse. Or let me find first rho. Rho is hypotenuse, y is opposite, x is adjacent. Pythagoras, hypotenuse square is side square plus side square. From this, hypotenuse rho is under root of x square plus y square. Similarly, when you apply tan phi is equal to y by x, opposite by adjacent. From this, phi is equal to tan inverse of y by x. This is how you can convert Cartesian to cylindrical. Now, cylindrical to Cartesian. I want x, y, z. Z is z, no conversion. I want x and y. Very simple. Now, if you consider sin phi, opposite side is y. By hypotenuse is rho. From this rho is y is rho sin phi. If you consider the adjacent side, cos phi is adjacent by hypotenuse. X is rho cos phi. X is rho cos phi. Y is rho sin phi. Z is z. This Cartesian to cylindrical coordinate system conversion. Is that clear? Any doubts? Cartesian to cylindrical. Sorry. Cartesian to cylindrical and cylindrical to Cartesian done. Next. Cartesian to spherical r theta phi. If you want r here, take the projection. Take the projection, and this length is r. Angle from z axis to r is theta. The line that is parallel to rho, this is one more rho. This is one more rho. Now this is falling at 90. The one opposite to 90 is hypotenuse. Hypotenuse square is side square plus side square. Hypotenuse square r square is rho square. Length on z axis is z square. But you know rho square is x square plus y square. R square is x square plus y square plus z square. R is under root of x square plus y square plus z square. That's R value. Similarly, if you find theta value, theta is equal to tan inverse of rho by z. But I want in Cartesian rho is under root of x square plus y square. Therefore, theta is equal to tan inverse of under root of x square plus y square by z. Similarly, phi is tan inverse of y by x. This Cartesian to spherical. Now, if you take spherical to Cartesian, I want x, y, z. And we already know that x is rho cos phi, y is rho sin phi. Rho is cylindrical coordinate, phi is both cylindrical and spherical coordinate. If you are able to write rho in terms of spherical coordinate, the complete equation will change to spherical coordinate system. So, how to write rho in spherical coordinate system? Here, rho is the opposite side. Apply sin theta. Sin theta is equal to rho by r. Therefore, rho is equal to r sin theta. Cylindrical coordinate is changed to spherical coordinates. Just replace rho by r sin theta. X is rho cos phi. Rho is r sin theta cos phi. Y is rho sin phi. R sin theta sin phi. Now z is adjacent side. Applying cos phi. Cos phi is equal to z by r. Therefore, z is equal to. So cos theta is equal to z by r. From this, z is equal to r cos theta. This is point transformation here. How to convert a point from one coordinate system to another coordinate system. Is that clear? Good afternoon, Deva. Tell me, dear. Deva, please tell me. What's the doubt? What's the doubt, dear? That's about point transformation. And we went for unit vector relations. How unit vectors are interrelated. For Cartesian Ax, Ay, Az. For cylindrical aero A phi AZ, spherical AR A theta A phi, how these are interrelated. It's a very good topic that we'll see in unity vector relations. Then we try to understand how to write the differential length, differential surface and differential volume in all the three coordinate systems. And also we got a shortcut for this so that one formula is enough for all the three coordinate systems. That's for dl, ds, dv. And also we written how to write divergence, curl, gradient and Laplacian in all the three coordinate systems. So clear? So that is what we have discussed under coordinate system here. These shortcuts are very, very important. And I took an overall of 15 hours to finish only these basics here. That's why basics are very, very important. For complete module 1, basics is a very important concept here. If you are thorough with basics, then things will become easy in static field theory and time varying field theory here. After basics, we went for static field theory. What we have learned under static field theory here? I'm doing good, Deva. How are you, dear? Next is static field theory. In electrostatics, the generalized law that governs electrostatics is Coulomb's law. What is Coulomb's law here? Coulomb's law will discuss about force between 2 point charges. Coulomb's law will discuss about force between 2 point charges. And from force we get electric field as force per unit charge. And we have seen applications of Coulomb's law. Applications of Coulomb's law we discussed on line charge, surface charge and volume charge. We have done all the derivations related to those applications useful for engineering services exam. This Coulomb's law is a generalized law that governs electrostatics. Then we went for Gauss law. Gauss law is a special law which can be applied only under the conditions of a Gaussian surface is given to us. And the Gaussian surface is something which is symmetric with respect to charge distribution. Gauss law states that the amount of flux cut by any closed surface is equal to the charge enclosed by the surface. IE is equal to charge enclosed. And Coulomb's law states that the force between any 2 point charges is always along the line joining them is directly proportional to the product of charges is inversely proportional to the square of distance between them. F is proportional to Q1 Q2 by R square of A, or F is equal to Q1 Q2 by 4 pi epsilon naught R square, where K is equal to 1 by 4 pi is a proportionality constant. The special case Gauss law, where Gaussian surfaces are defined We define Gauss law and the applications of Gauss law. We define it over point charge, line charge, surface charge and volume charge. Then we derived electric potential, also called as EMF, electromotive force. And we have seen relation between E and V given by E is equal to minus del V. These are the main topics that we have discussed in electrostatics. In magnetostatics, just like you have Coulomb's law, which is a generalized law that governs electrostatics, we have Biot-Savart law, the generalized law that governs magnetostatics. And we have seen their applications. For line current, surface current and volume current. Then we went for Ampere's law. According to Ampere's law, the circulation of H is equal to current enclosed by the loop. Specialized law, special law, it can be applied only when an Amperean path is defined. An Amperean path is one which is symmetric with respect to current distribution. Hello, good evening, Bhupati, how are you? Good evening, dear. Good evening. I'm doing good, dear. New educators has joined our channel, dear. I hope you got the news. So follow the new educators. We all are starting the new sessions from Monday. From Monday, I will start transmission lines, and all the other faculties are also gearing up to start the new concepts. And we are on track to finish the syllabus comprehensively for GATE 2023 and Engineering Services 2023. So inform all your friends here, we'll rock the sessions. As you already know that elements of EMF theory done, 90% of EM wave propagation is done, 38 to 40 hours of antennas we have dealt. Maximum in EMFT, what we are left out with is transmission lines and waveguides. Those topics will start from Monday. So, according to Ampere's law, the closed loop integral of H dot dl, or The Lential law of tangential component of magnetic field intensity around a closed loop is equal to the current enclosed by the loop. True form. Ampere's law. Ampere's law is applicable only when we define an Amperian path. But in applications of Ampere's law for line current, surface current and volume current, just like electric potential, we define scalar magnetic potential given by Vm, also called as MMF. Magnetomotive force, just like electromotive force is voltage, magnetomotive force is current. But there is a problem with MMF, which you call it as failure of MMF. Can someone tell me what is failure of MMF? What is failure of MMF? Magnetomotive force or scalar magnetic potential cannot be defined in the region where sigma is present or conductivity is present. Wherever there is conductivity, MMF cannot be defined. The derivation for the same is being derived in the playlist here. Please go through the playlist. The derivation related to this topic is already in the playlist. Please go through it and understand. Whenever sigma is there, why MMF cannot be defined? I explained elaborately in that playlist. As this fellow cannot be defined everywhere, we introduce vector magnetic potential. That is vector magnetic potential given by A, which can be defined everywhere in the region. And also we have seen relation between A and B. Just like you have relation between A and B, here we have relation between A and B given by del cross A is equal to B. If you compare this here, this is generalized law that governs electrostatics and this is generalized law that governs magnetostatics. This is the special law that governs electrostatics. This is the special law that governs magnetostatics. Here we need a Gaussian surface, here we need an Amperian path. Gaussian surface is symmetric with respect to charge distribution. Amperian path is symmetric with respect to current distribution. Here we have electric potential EMF, here you have magnetic potential MMF. Here relation between A and B is minus del V, here relation between A and B, del cross A is equal to B. That's why if you see carefully here, both are very closely related topics. The common topics that we have discussed, are work done and energy density. How they are interrelated? Derivative of work done is energy density. If this is work done, the small part is energy density. Derivative of work done is energy density. This work done is represented by capital W, energy density by small w. It is also one way to understand the derivative of W. Capital W is small w. So we have derived work done and energy density in both electric fields and magnetic fields. Common topic. We have derived Poisson's and Laplace equations. We have derived Poisson's and Laplace equations also for both electric field and magnetic field. Then we derive boundary conditions We derived boundary conditions. Again, both for electric field and magnetic fields. And for electrostatics, we have seen capacitors and types. Magnetostatics, we have seen inductors and types. Work done and energy density. Here we got work done. It's 1 by 2 volume integral of d dot d dv. And for the derivation for the same, please go through the playlist. D is epsilon naught d. It's 1 by 2 volume integral of epsilon naught d square of dv. E is d by epsilon naught. This is work done for electric field. Similarly, work done in magnetic field. D is replaced by B, E is replaced by H. B dot H dV, 1 by 2 volume integral, B is mu naught H. Mu naught H square dV. One by 2 volume integral of B square by mu naught of dV. This is work done. Derivative of work done gives you energy density small w capital E. We do derivative d by dV of this value, volume integral of 1 dV V, d by dV of V, which is 1. Therefore, energy density is given by WE is equal to 1 by 2 d dot D. 1 by 2 epsilon naught E square or D square by 2 epsilon naught. Similarly, energy density in magnetic field small w capital M is derivative of work done. 1 by 2 V dot H. 1 by 2 mu naught H square, B square by 2 mu naught. These are the common topic here. Work done and energy density for both electric and magnetic fields. Is it clear? It's work done and energy density. This is Poisson's and Laplace equations. Poisson's and Laplace equation. Electric field. Poisson's and Laplace equations. From Gauss law, del dot D is rho V. D is equal to epsilon naught D. Del dot epsilon naught D is rho V. Del dot D rho V by epsilon naught. E is minus del V. Del dot minus del V is rho V by epsilon naught. This is called Poisson's equation. For inhomogeneous medium. And when you consider homogeneous medium, del dot del, this del square V, this minus will go to RHS, is equal to minus rho V by epsilon naught. This is Poisson's equation. Homogeneous medium. In this case, when rho V is 0, the charge is 0. The equation that we get is rho V del square V is equal to 0. This is Laplace equation. And del square is called Laplacian operator. That's a derivation for Poisson's and Laplace equation. That's for electric field. If you go for magnetic field, del cross H is equal to J from Ampere's law. B is equal to mu naught H. H is B by mu naught, del cross B by mu naught is equal to J, or del cross B is mu naught J. B is del cross A from relation between A and B. Del cross A is equal to mu naught J. This is from the vector identity A cross of B cross C. C into A dot B minus B into A dot C. Substituting A cross B cross C is equal to A into del dot del minus del of del dot A is equal to mu naught J. Del square A minus del of del dot A is equal to mu naught J. From Gauss transformation, when del dot B is equal to 0, B is equal to del cross A, B is equal to del cross A, and del dot B is equal to 0, del dot B is 0 and B is del cross A. Orientation of A gives B and such B divergence is 0. Therefore, source divergence is also 0. From this del dot A is also 0. In simple words, del dot A is 0 because del dot B is 0, and the resultant of A, orientation of A is B. As a resultant divergence is 0, source divergence will also be 0. It implies del square A is equal to considering the mu naught J here, one second here, sorry. When vector triple product A cross of B cross C, B into A dot C minus C into A dot B, back minus cap rule. Sorry dear, the other time I took reverse. Substituting del of del dot A minus A into del dot del equal to mu naught J. Del of del dot A minus del square A is equal to mu naught J, as I explained earlier, as del dot B is equal to 0, B is equal to del cross A. Therefore, orientation of A is resulting in B and such B divergence is 0, implies source divergence is also 0. From this you got del dot A is 0. From this del square A is equal to minus mu naught J, Poisson's equation, and if J is 0, Laplace equation del square A is equal to 0. These are Poisson's and Laplace equations. Next, boundary conditions. Yes, Bhupati. What are the boundary conditions that we are having here? What are the boundary conditions that we have? Dielectric boundary conditions. Dielectric boundary conditions. The boundary conditions prevailing between two dielectrics. The boundary conditions are: tangential component of electric field intensity is continuous across the boundary of discontinuity. That means tangential component of electric field will not vary. And the derivation for each of these boundary conditions are given in the playlist here. Please go through the playlist of elements of EMF theory. Complete boundary condition derivations will be available. Second one, dN1 is equal to dN2 if and only if rho s is 0. It means Normal component of electric flux density is continuous across the boundary of discontinuity if and only if rho s is 0, where rho s is the surface charge that is deliberately placed on the boundary. Before simplification, you will get it like dn2 minus dn1 is equal to rho s. Third one, st2 minus st1 is equal to k cross an. This is vector notation. If you apply the condition, k is 0, ht1 is equal to ht2. Tangential component of magnetic field intensity is continuous across the boundary of discontinuity if and only if the surface current k is equal to 0. Bn1 is equal to Bn2. Normal component of magnetic flux density is continuous across the boundary of discontinuity. It is unconditionally continuous. It is unconditionally continuous. Is that clear? Next, dielectric conductor boundary conditions. Dielectric conductor boundary conditions. Conductor in the sense perfect conductor. As you know, field cannot exist in any perfect conductor. If you consider the first medium to be the dielectric medium and the second medium to be the perfect conductor, then in a perfect conductor, electric field does not exist, ED2 will become 0. Therefore, we get E tan is equal to 0, tangential component of electric field intensity is equal to 0. On a dielectric conductor interface, the tangential component of electric field on the surface of the perfect conductor is 0. Similarly, if you make one region 0 here, we got d normal is equal to rho s. Normal component of electric flux density is equal to surface charge density on the surface of a perfect conductor. Similarly, st1 is 0 here, so we get h tan is equal to k cross an. The tangential component of magnetic field intensity, h tan is equal to k cross an. Last one, B normal is 0. These are dielectric conductor boundary conditions. These are dielectric boundary conditions. The difference between dielectric boundary condition and dielectric conductor boundary condition is, here the dielectric is replaced by a perfect conductor and no field component exists within a perfect conductor. So thereby substituting the component values, the first one you get E tan is equal to 0, tangential component of electric field intensity on the surface of perfect conductor is 0. In the second one we get d normal is equal to rho s, normal component of electric flux density is equal to surface charge density, and which is this rho s is the charge that is deliberately placed on the boundary. Third one, h tan is equal to k cross an. Tangential component of magnetic field intensity is equal to k cross an. This reminds that h and k both have same unit, but they never travel in the same direction. They take the perpendicular directions. And in this case 0, st1 is equal to st2, conditionally continuous. Then bn1 is equal to bn2. Normal component of magnetic flux density is continuous across the boundary of discontinuity. Dielectric boundary condition, and its value is 0 for a dielectric conductor boundary condition. Next, in electrostatics we have defined capacitors and N types, and in magnetostatics inductors and types. Capacitors and types. Parallel plate capacitor. Consider a parallel plate capacitor having an area A, dielectric surface as air, epsilon naught permittivity. S is the surface area on each plate. And for this also we have done some wonderful derivation for the same. And we got for a parallel plate capacitor, capacitance is equal to epsilon naught A by D. A is the area of the plate and D or S is the area of the plate and D or S is the distance between them. That's for parallel plate capacitor. Next, coaxial cable. If you consider a coaxial cable, of length L, inner radius having radius A and outer conductor having radius B, then the coaxial cable capacitance C is equal to 2 pi epsilon L by ln of B by A. B is the radius of the outer cylinder, A is the radius of the inner cylinder. L is the total length of the coaxial cable. Third one is the spherical capacitor. Spherical capacitor has two spheres, one inner sphere of radius A, outer sphere of radius B, as shown here. The capacitance, again wonderful derivation on this also. 4 pi epsilon 1 by A minus 1 by B. And if you make this radius to infinity, this inner sphere will become isolated sphere. In that case, here B is infinity. Therefore, the capacitance of isolated sphere of radius A is 4 pi epsilon A. Clear? That's about capacitors. In solenoid, L is equal to N square mu A by D. N square mu A by D. This is for a solenoid. This is for a solenoid here. For a toroid, L is equal to N square mu A by 2 pi R. These are the redundant topics that we derived. And static field theory, of course, we derived Maxwell equations other than this. We derived Maxwell equations. And of course we derived Maxwell equations for static fields. Derived Maxwell equations for static fields. Okay. What are the Maxwell equations that we got here? First equation. Otherwise, I'll write equation number and all. Wait 1 second. Yeah. Equation number integral form differential form and source. Equation number 1, closed surface integral of d dot ds is equal to volume integral of rho v dv. Differential form del dot d is equal to rho v. Source, Gauss law for electric fields. Second, closed loop integral of E dot dl is equal to 0. Differential form del cross E is equal to 0. Curl of E is 0. Rotation of E is 0. It is irrotational. Static electric field is irrotational in nature. This is called conservative property of electric field. Third one, closed loop integral of H dot dl is equal to current enclosed. This is true form. This can be replaced by open surface integral of J dot ds. This is integral form. Applying Stokes on LHS. Del cross H is equal to J. This is from Ampere's law. Fourth equation, closed surface integral of B dot ds is equal to 0. Implies del dot B is equal to 0. Source, Gauss law for magnetic fields. Also called as non-existence of magnetic monopole. A magnetic monopole does not exist. A magnetic monopole does not exist. So these are Maxwell equations for static field that we have derived from static field theory. Any doubts? Any doubts, dear? Let us derive these laws, dear. First law, Maxwell's first equation. Closed surface integral of d dot ds is volume integral of rho v dv. Differential form del dot d is equal to rho v. Source, Gauss law. For electric fields. So what is Gauss law? Let us see. According to Gauss law, the amount of flux, according to Gauss law, the amount of flux that is cut by any closed surface is equal to the charge enclosed by the surface. Therefore, Gauss law in true form is psi E is equal to charge enclosed. This is true form. Now here psi E is electric flux density divided by surface area. But here we got psi E is equal to charge enclosed. How psi E is related to electric flux density, we'll see. Electric flux density D is psi E by S. Electric flux per unit surface area, unit Coulomb per meter square. When you consider small surface area ds, the flux associated is d psi E. From this d psi E is equal to d into ds. Psi E is equal to closed surface integral d dot ds. That's psi E. Now if you go for charge enclosed, if you consider a line carrying a charge q and having a length L, this line is supposed to have uniform line charge density rho L given by total charge by total length, unit Coulomb per meter. If you consider a small length in it, dl, the charge associated with it is dq. The scalar, you can write one more step here. D psi E is equal to d dot ds, vector notation, dot product of any two vectors is a scalar quantity. From there you can write this step. So here rho L is q by L or Coulomb per meter. If you consider a small length dl, when you consider a small length dl, the charge associated is dq. From this dq is equal to rho L dl. Or q is equal to line integral of rho L dl. Similarly, if you consider a surface carrying surface area S, having surface charge density rho S, consider it to have some charge q, surface area S, rho S, surface charge density is total charge by total surface area, Coulomb per meter square. If you consider a small area in it, which is ds, the charge within that small volume or small surface is dq. From this it is rho s is equal to dq by ds. From this dq is equal to rho s ds. Q is surface integral of rho s ds. Similarly, if you consider a volume, this volume is supposed to have uniform volume charge density rho v. Uniform volume charge density of rho v. It's carrying a charge q. The total charge is q and the volume is v. Therefore, this structure carries uniform volume charge density. This q by v. If you consider small volume dV, the charge associated with it is dq. From this dq is equal to rho v dV. Q is equal to volume integral of rho v dV. As it is the most generalized form, we take volume integral of rho v dv. So from Gauss law, psi e is equal to charge enclosed. In charge enclosed, we got it as the most general form, volume integral of rho v dv. From Gauss law, psi e is equal to charge enclosed. Closed surface integral of d dot ds is equal to volume integral of rho v dv. This is integral form. Applying divergence on LHS, closed surface integral of d dot ds is equal to volume integral of del dot d dv. The practical example I already explained in the previous classes. Please refer the playlist for the derivation for the same. Is equal to volume integral of rho v dv. Comparing, we get del dot d is equal to rho v. We get del dot d is equal to rho v. This is the differential form. This is the integral form. This is from Gauss law for electric fields. Next. Conservative property of electric field. That is del cross E is equal to 0. Electric field is conservative. It is irrotational. It cannot be rotated. Its curl is 0. How to find this? Work done is equal to force into displacement. Work done is scalar quantity, force and displacement are vector quantities. Therefore, work done is F dot L. F is electric force, which is equal to Q into E. This is Q into E dot L. The complete work done is this. If a small work done is considered, is moving a charge Q in the presence of electric field, E by displacement dl, dw is Q into E dot dl. From this, W is equal to Q into integral of E dot dl. That's work done. From this, electric potential is equal to work done per unit charge. This is integral of E dot dl. But again, considering the assumption of Heinrich Friedrich Emil length and considering an external agent is doing the work, whenever you assume that the external agent is doing the work, you'll get this negative sign here. Therefore, V is equal to minus line integral of E dot dl. Is that clear? V is equal to minus line integral of E dot dl. This is for any path L. If you assume that it contains two corners A and B, VAB is equal to VA minus VB. We are going from B to A, minus integral B to A E dot dl. This is the potential difference here. Now, if you extend it up to C, you get a VAC is equal to VA minus VC. Extend up to D, VAD is equal to VA minus VD. Extend up to A, VAA is VA minus VA 0. That means when you close the loop, the value is becoming 0. Closed loop integral E dot dl is 0. This is called integral form of Maxwell's second equation, applying Stokes theorem, closed loop integral of E dot dl is equal to surface integral of del cross E dot ds. From this we get del cross E is equal to 0. Conservative property of electric field. This is from the conservative property of electric field, indicating that the rotation of E is 0. The integral form, and this is a differential form of Maxwell's second equation. Any doubt, dear Bhupati? Any doubt, please let me know, dear. That is second one, from conservative property of electric field. This is done. This is done. Next is Ampere's law. According to Ampere's law, the closed loop integral of H dot dl is equal to the current enclosed by the loop. This is called the true form. This is called the true form of Ampere's law. This I enclosed is related to J as J. Current density is equal to current per unit surface area. Unit ampere per meter square. If you consider small surface area, ds current is di. J is di by ds. From there, gi is equal to j into ds. Scalar notation and vector notation, di is equal to j dot ds. From this, I is equal to surface integral of j dot ds. Therefore, closed loop integral of h dot dl is equal to surface integral of j dot ds. Integral form of Maxwell's third equation. Applying Stokes on LHS, closed loop integral of h dot dl is equal to surface integral of del cross h dot ds is equal to surface integral of j dot ds. Removing the integral, we get del cross h is equal to j. We get del cross h is equal to j. That's the differential form, okay? Last one. In a permanent magnet, whenever you try to bifurcate this permanent magnet, it will again form north poles and south poles subsequently. And the magnetic flux will move from north pole to south pole. Outside the magnet, we are having a uniform magnetic field psi m moving from north pole to south pole. And inside the magnet, it moves from south pole to north pole, forming closed loops. Forming the closed loops. And from this, we can say here, the net flux is 0. If you take magnetic flux density, it's magnetic flux per unit surface area, Weber per meter square, and after the great scientist Nikola Tesla. Consider small surface area, ds psi is The flux is d psi m. D psi m by ds. From this d psi m is equal to b into ds. The psi m is equal to surface integral of b dot ds. Psi m is equal to surface integral of b dot ds. Is that clear? But here the amount of flux that is radiated by the magnet is psi m. The amount that is consumed is also psi m. So net flux is 0. Substituting closed surface integral b dot ds is equal to 0. That is the integral form. Differential form applying the divergence theorem on it. We get del dot b is equal to 0. This integral form and this differential form. One is integral form and the other is differential form. These are the four Maxwell equations here. For static fields. These are the four Maxwell equations for static fields. Next. That is the static field theory. Next is time varying field theory. In time varying field theory, we derive Maxwell equations for time varying fields. First, equation 1. Closed surface integral of d dot ds is equal to volume integral of rho v dv. Integral form. Differential form del dot d is equal to rho v. Source Gauss law. Second one. Closed loop integral of v dot dl is equal to surface integral of minus dou b by dou t dot ds. Integral form, differential form says that del cross E is equal to minus dou b by dou t. From Faraday's law. Third one, closed loop integral of h dot dl is equal to surface integral of j plus jd dot ds. Differential form del cross H is equal to J plus JD. J is sigma E is conduction current density, JD is displacement current density, dou D by dou T. And if you see these two equations here, spatial orientation of electric field now depends on time varying magnetic field, and similarly spatial orientation of magnetic field depends on time varying electric field. Now they are interdependent, which is the necessary condition for B fields to be a part of EM wave. Closed surface integral B dot ds is equal to 0. The fourth equation. Applying divergence on it. Del dot B is equal to 0. Is that clear? And this is from inconsistency of Ampere's law or Maxwell contribution. And this from Gauss law. So this for Gauss law for electric field, this Gauss law for magnetic fields. With this we have completed Maxwell equations for time varying fields. Here two things that were added or changed are these two. One is Faraday's law, other is from Maxwell contribution. Clear? Yeah. Is it clear? These are Maxwell equations for time varying fields. Maxwell equations for time varying fields, where we have derived Faraday's law. Any closed path is equal to the rate of change of flux linkage d lambda by dt, where lambda is a flux linkage given by n psi m. N is number of turns. And psi m is the magnetic flux. Later on, scientist named Heinrich Friedrich Emil Lenz said that the induced EMF always opposes the flux produced it. Introduce the negative sign there, from which you got VEMF is equal to minus lambda is n psi m, n times of d psi m by dt. If you consider a straight conductor, for a straight conductor n is 1, VEMF is equal to minus d by dt of psi m. VEMF, V and E are related as VEMF is equal to closed loop integral of E dot dl. Remember, negative sign is not applicable here because external agent is not doing the work, first thing. Second, even though you close the loop, it will not become zero because only static electric field is conservative in nature but not time varying electric field. These two important points you need to understand. Actually, the general relation is V is equal to minus integral of E dot dl. This negative sign is because of my assumption that an external agent is doing the work. Is not valid in time varying fields. So plus, and you can close the loop. Even though you close the loop, the value will not become zero because only static electric field is conservative. Only for static electric field, del cross C is zero. Its rotation is zero. It is irrotational, but not for time varying electric field. If VEMF is equal to closed loop integral of E dot dl is equal to minus d by dt of psi m, surface integral of B dot ds. Implies closed loop integral of E dot dl is equal to surface integral of minus dou b by dou t dot ds. Integral form, differential form. Closed loop integral of E dot dl is equal to surface integral of del cross E dot ds. Stokes theorem. Applying Stokes theorem. Once you apply Stokes theorem, you get surface integral of del cross E dot ds is equal to surface integral of minus dou b by dou t dot ds. This implies del cross E is equal to minus dou b by dou t. Differential form or point form. This one. Faraday's law. Next is Maxwell contribution. Next is Maxwell contribution. Also called as inconsistency of Ampere's law. What Maxwell proved is that Ampere is inconsistent. Del cross H is equal to J from Ampere's law. He took Ampere's law and he had done divergence on both sides. But what you got here is divergence of curl of any vector. That must be 0 from vector identity. So from vector identity we got del dot J is equal to 0. But from continuity equation del dot J is equal to minus dou rho V by dou T. What is continuity equation? Continuity equation is from conservative property of charge. And what is conservative property of charge? According to conservative property of charge, the amount of charge that is decreased in a closed volume, the amount of charge that is decreased within a closed volume is equal to the net outgoing current. The rate of decrease of charge within a closed volume is equal to net outgoing current. You know, Q is related to rho V as Q is volume integral of rho V dV. I is related to J as surface integral of J dot ds. Already, these formulas already were derived in the previous derivations in this same class. Please refer them. Then you get minus d by dt of Q in is volume integral of rho V dV. Is I out is surface integral of J dot ds. This implies surface integral of J dot ds is equal to volume integral of minus dou rho V by dou T of dV. Applying divergence theorem, closed surface integral of J dot ds is equal to volume integral of del dot J dV is volume integral of minus dou rho V by dou T of dV. Removing the integral you get del dot J is equal to minus dou rho V by dou T. It is from continuity equation. And continuity equation is from the natural phenomena called conservative property of charge and which cannot be wrong. So this fellow is not wrong. There must be some problem in Ampere's law. So what Maxwell has done is that modified the this Ampere's law. He had added a term called JD, which is called displacement current density. Displacement current is, in simple words, it's a current which can flow in air. Then again he had done divergence on both sides. Divergence of curl of any vector is 0. 0 is equal to del dot J plus del dot JD. This implies del dot JD is equal to minus del dot J. From continuity equation del dot J is equal to minus dou rho V by dou T. Substituting del dot JD is equal to minus dou rho V by dou T, minus plus dou rho V by dou T. From Gauss law we know del dot D is equal to rho V. Substituting del dot JD is equal to dou by dou T of del dot D. Implies del dot JD is equal to del dot dou D by dou T. Implies JD, displacement current density, is equal to dou D by dou T. Substituting you get del cross H is equal to J plus JD, where J is conduction current density sigma E, JD is displacement current density dou D by dou T. These are modified Maxwell equations or Maxwell equations for time varying fields. With this we had completed the module 1. This is the module 1 concepts. We'll do some problems on this as our series is concepts through questions. Basing on these concepts, we'll do some more problems in the upcoming class. And if you see the time varying field equations here, the Maxwell equations from Faraday's law, Del cross E is equal to minus dou B by dou T from Maxwell contribution. Del cross H is equal to J plus JD, or J is conduction current density, which is sigma E, which depends on conductivity of the material, and JD is dou D by dou T, displacement current density, depends on time varying electric field. Now if you see these two equations carefully, spatial orientation of electric field depends on time varying magnetic field, and spatial orientation of magnetic field depends on time varying electric field. There is interdependency between these fields, which is a necessary condition for a wave. Therefore, combining these two equations, we get wave equation. Wave equation is given by Helmholtz equations. Helmholtz equations are del square E is equal to gamma square E, and del square H is equal to gamma square H, where gamma is called the propagation constant, which is under root of j omega mu sigma minus omega square mu epsilon. Clear? This we'll see some more concepts, some more questions in the next class. Thank you all, dear. Thank you all for joining. Have a great day.